So welcome, everyone. We have to stick to a timeline, so I'm going to be fairly quick in yielding the floor. But I'd like you to listen through a couple of filters to the presentations you hear today. And one of them is don't be overwhelmed by what looks like bad news. Because if there's a bear in your living room, it's actually good to have that information. So we're going to be learning about a sum of challenges that is lately being called the polycrisis. And the information is empowering. The second thing is, in your own world, in your own profession, in your own circle of influence, listen to the presentations and engage as possibilities for action. What actions can you support? What actions can you undertake? The logistics of today's meetings are as follows. You are not witnessing a meeting of the Sustainable and Resilient Resources Roundtable. You are now in the Sustainable and Resilient Resources Roundtable, so you are part of it and a contributor. Because of the large numbers today, our presenters and respondents will be speaking, and we have some excellent facilitators helping. When you have questions and comments, please put them into the chat. And the respondents for each presentation will be watching the chat, and your question can be pulled during one of two times, the question and answer period, or during the discussion at the end. So I would like now to welcome Dr. Sandra Faber to lead off this discussion with her wonderful presentation, which I have seen. And I haven't seen her deliver it, but I've seen the PowerPoint. And Sandra's was emphasizing that we should mention action throughout the workshop series, and so I did, and she will. You have the bios. I sent out bios to everyone that had registered before mid-morning today. So rather than give the long bios, I welcome presenters to say a word or two about yourself that isn't in your bio, and the other folks can check their emails and read a little more detail about the people. Sandra Faber, welcome. We're starting a couple minutes early.
David,
Yes.
Before we start, I'm in the chat. The option for everyone I see is meeting group chat, and then you have to go in, if this is the correct one, and then it says you have to go into, well, maybe, wait a minute, of course, now
people can choose who to chat to. They can send private messages.
Right. It was okay, so I just set the agenda. It's, and I'll send it again in a little while. Okay. But it's in the chat for whoever would like.
Okay, the agenda's in the chat. You can ask your questions in the chat, and I yield the floor to Sandra Faber to begin the discussion.
Thanks very much, David. You've sent around my bio, but I thought I would start with a few words about how I came to this personally. As everybody will see at the end of my remarks, I am on the spectrum of hopefulness and pessimism. I am as far to the pessimistic end of things as I think most people could be. So prepare yourself for a presentation which is more honest than what I've been able to bring myself to deliver to other groups. I think that this group is prepared to hear remarks like this. I hope you are. And I hope you can push back, actually, and moderate my pessimism in some way. So coming to terms with societal collapse, that's my talk for today. I am past thoughts of mitigation. I actually think a collapse is ahead of us, and so I'm focused on how we deal with the collapse not really how we avoid it. So, as promised, a few remarks about me. I'm an astronomer and cosmologist, a staff member of the University of California Observatories and a faculty member at Santa Cruz. My research expertise is in galaxy formation and evolution, and instrumentation, the Hubble Space Telescope, and so on. But late in life, I had this thought: why is cosmic knowledge important to humanity? I've been spending my life accumulating information about how the universe forms, how the galaxy forms, how Earth forms. Why should people be interested in this? Not just aesthetically, but for practical reasons. And I answered my own question in the following way. I said, I think that this is knowledge that the average citizen needs to know as foundational knowledge for planning Earth's future. And we are at a pivotal point in the history of Earth where human civilization has taken over the planet and has the planet's fate in its hands. So we founded an Earth Futures Institute at UC Santa Cruz. I'll say more about that. It was originally designed to think about life on Earth on cosmic time, because I'm an astronomer. But actually, as I got more deeply into the subject, I come to the conclusion that near-term challenges need more attention than the thought of, or at least as much attention than the thought of how to organize life and its prospects over millions or even billions of years. So I've already told you my personal opinion, which is going to flavor this talk, that a major societal collapse is likely. And therefore, my question is, how do we get through it? And how do we ensure that essential elements of society today can survive into the next era? So the next 3 slides are an attempt to present my 3 reasons for thinking why a major collapse is inevitable. 3 chapters, if you will. So, this was a slide, sorry, on Earth Futures Institute. A very small group of faculty at Santa Cruz. And in the interest of time, I'll skip to activities and current focus. Over the next year, we hope to put together an 8-part video short course on energy, resources, climate, and geopolitics, with the purpose of educating university faculty. I listen to lots of podcasts on this topic. I think they're extremely valuable. I've learned so much from them, but they are sort of scattered, and it takes a long time to listen to them. Our faculty are extremely busy. My goal here would be to put together something a lot shorter that is very efficient, but unlike most presentations, covers the range of issues that I'm going to talk to you about today. So the Earth Futures Institute has done a few things, but not a whole lot thus far. And one of the reasons is that due to my pessimism, I felt challenged. I felt paralyzed. I don't know what to say to people. And in particular, I don't know how to talk to young people. I'm at a university. My job is to educate the young generation for their future. And I am looking forward to finding the right message that will both motivate, but nevertheless inspire young people to deal with what I think is coming in their future. All right, well, as promised, I've prepared 3 slides that summarize the 3 main threads that I think are important for understanding this polyclite crisis. And I'm going to start with a disclaimer and apology, and say that I'm speaking in a rather firm and confident tone of voice, but I really shouldn't be doing that, because I'm an astronomer, and yet the things I'm talking about today have to do with natural resources, energy, the economy, economics, and I'm not trained in any of those fields. I'm a newcomer, and therefore I should be speaking tentatively and humbly. And I hope you will take my intent to do so, even if I speak somewhat forcefully. All right, so the first chapter has to do with energy, and in particular oil. So we know that oil will end within a few generations, and how soon is of critical importance. Why? Because these 3 chapters that I'm going to discuss, the timing is super important. When is the first major stress going to arrive, and what will it look like? So a stress will be the end of oil. One of the things that we need to understand for planning is when that is going to happen. It's very hard to figure that out because oil-bearing countries keep rather close the information about what their reserves look like. So I don't know when oil will end, and I don't know how it will end. It certainly won't end suddenly. It will probably end by becoming gradually more expensive. And what will the effect of that be on the economy? Major question. Now, oil is irreplaceable for some things: transportation, cement, steel, and fertilizers. And people talk about ways in which we might mitigate this. For example, we might convert the electrical grid to renewables, wind and solar. But there's a study by Simon Michaud, which argues that there's not enough minerals in the Earth's crust to be extracted on any meaningful timescale that would allow rebuilding the electrical grid. So that's one of the first things I want to say today, is I don't believe in some supposed mitigations, and this is one of them. I don't think we're going to have an electrical grid that's converted to renewables on any timescale that really helps. Another mitigating strategy that people talk about is electric cars. I actually think that electric cars are a negative. Why is that? Because if you do a lifetime study of an electric car with current battery technology, it hardly saves any energy if you are generating electrical energy from fossil fuels, that's for sure. Even if you generate your electrical energy from renewables like hydro or wind and solar, it's only a 30% savings. That's not huge in the context of the problem we're trying to solve. And furthermore, in some ways, it's much worse because the batteries and the aluminum that you need to build it place a bigger stress on the environment. So I don't think that electric cars are particularly helpful. Another example of what I believe we're being told by media and the powers that be, that we can solve all of these problems. When we look in more detail into these strategies, I don't think that they're very helpful. And furthermore, renewable energy strategies cannot substitute for certain unique uses of oil. You cannot power trucks with batteries. You cannot power ships with batteries. You can't generate the high heat needed to make steel with renewable energy. Same for cement and fertilizer. You need chemical uses of petroleum. Okay, so conclusion number 1 from this chapter is that the uses of oil are, some uses are absolutely irreplaceable. We will therefore not be significantly able to wean ourselves off of oil. And furthermore, when you think about the way our lives are structured today, the end of oil will be the end of life as we know it. So this is a very pessimistic message from chapter 1. Okay, moving to chapter 2 is the question of oil or fossil fuels and climate change. Since I don't think we'll be weaning our way off these energy sources as long as we have them, I assume that we will burn what we have. And I'm going to assume that we've burned half of oil and probably less than half of coal. If we burn all of these things, then delta CO2 in the atmosphere will double from what it is today over pre-industrial levels. And this recent paper by James Hansen and his collaborators argues forcefully, based on paleoclimate data, that this means a warming of 4.8 plus or minus 1.2 degrees, which is on the high side of what people are talking about. All right, so now if we burn this fuel, what are the mitigations? One is direct carbon capture. I've been looking into that, reading articles, and from my point of view, it seems as though it's energetically unfeasible. It takes about as much energy to take the CO2 out of the air as we got from burning it in the first place. There'll probably be some improvements there, but they're of the order of factors of 2 or 3, not factors of 10 or 100. And furthermore, you have to build these capture plants, and they will consume materials in the process that are analogous to what Simon Michaud has already told us is infeasible for rebuilding the electrical grid. So I don't think we have the raw materials in the Earth's crust available to build these DCC plants. So if we're going to burn this fuel and warming is of the order of 5 degrees, by the end of the century, 2 billion people, a quarter of Earth's population, will either have to move or die because their homelands are uninhabitable. And by uninhabitable, I really mean that. Without air conditioning there, you would die. But well before that, crops will fail, and that will force massive migrations. And even before that, occasional heat waves will claim many lives, as outlined in the brilliant book, Ministry of the Future, by Kim Stanley Robinson. This was the opening chapter. 20 million people died in India in his book. And it's realistic. He picked exactly the right topic to open that book. And as these pressures accumulate, governments will become increasingly unstable. So just to put this in more concrete terms, there are right now 2 million people waiting at the southern US border for entry. And picture a quarter of the people in the Western Hemisphere, that is to say, 0.5 billion people in the future poised on the southern border of the United States. Immigration is tearing this country apart, and we haven't seen anything yet. Chapter 3 is about economics, and I'm probably least qualified to speak on this topic. I've asked my economics friends some of these questions, and it's quite amazing that I don't really get clear answers back. So some of the conclusions on this slide are really my own, largely, but some people have ratified them, people I listen to and books that I have read. So it is my opinion that our modern capitalist economy is a Ponzi scheme that is predicated on endless growth. There are a couple of reasons for this, but one very clear one, I think, is the fact that banks make loans and they're repaid not just with principal, but interest. That is, they get more money back than they sent out. So where does that extra money come from? I believe it comes from economic growth. Now, you could make a loan, 2 people could make a loan between themselves, and you wouldn't require the economy to grow. But what's important here is that everybody is doing this. This practice of taking out loans and repaying interest is it's earth-wide, it's global. And it's the global nature of this that really requires global economic growth. So there are 2 problems here. Over the last century or so, economic growth has needed more oil. And statistically, a 1% increase in world GDP has gone along with a 0.5% increase in oil. We're getting more efficient, but nevertheless, the absolute amount of oil that we're using is increasing. So my first question is, what happens to the economy if oil doesn't grow or gets much more expensive? does this precipitate some kind of financial collapse? And my problem number two is kind of related. In our economy, if you think about it, these loans are a fixed fraction of economic activity. And the economy is growing at some percent per year. If that percent is constant, then we're in exponential growth. And many people are saying that we can't have an economy that grows exponentially because it will outstrip the limits of the planet. My focus here is on the growth of debt growing exponentially. And I ask how debt is to be paid off. There are two ways. One way, you can pay it off with real assets. You know, you owe me something and you give me a car to pay off the debt. That's real. But it has been estimated by Nate Hagens that if we paid off all current debt with real stuff, that would require raw materials and resources from the Earth's crust. And he believes that global debt exceeds the resources available in the Earth's crust needed to pay it off. A very interesting perspective. The other way of paying off debt is with money, which is worthless in itself, and it can inflate. And this is one of the best strategies that governments have used to pay off their national debt when that becomes excessive, inflated currency. So I'm guessing that in the near future, we're going to face some massive inflation. And I'm really completely mystified by the Federal Reserve's belief somehow that it can restrain inflation when, in fact, our debt is mounting to the point where the government is going to need inflation to pay it off. And that's my point here at the bottom of this slide. The federal debt has doubled every 9 years since 1980, and it's now $31 trillion. At 5% interest on that debt, treasuries are now at 5%. That would be an annual financing cost of $1.5 trillion annually, which is 25% of the federal budget. This year, we're at 13%. Next year, if things continue, we could be at 25%. When you are paying off a national debt and it's requiring a quarter of your operating budget, you are entering desperate territory. And so I am wondering whether mounting debt, not just the national debts, but debt of corporations and the total amount of debt on the planet, I'm wondering whether this is going to be another looming limit to continued economic growth. And I said a while ago that I was unsure about the timing of these things. The end of oil, that's a timing issue. Global warming and the dangers from that, that's a timing issue. And now my third chapter here also has a timing issue. And of the three, I'm thinking actually that some massive economic readjustment might be the first thing that happens to us because of this point in my last paragraph here. Next year already, we may face an absolutely unprecedented circumstance in the US economy. Okay, so those are my three chapters, each one of them pretty grim. So now I'm asking the question, what should we be doing? Stressing the need for action. So if you think that societal collapse is actually going to happen, what do you do? I have three things here, but I'm sure you could think of more. The first thing is, what does it look like? We shouldn't just be sitting here on our thumbs saying, oh, things are going to collapse. Shouldn't we be thinking about what's going to happen and what we should be doing as communities and individuals to get through this? So it seems to me that realistic model scenarios are highly desirable here. And I think this is expensive because this collapse involves the whole planet and many different aspects: energy, the economy, food production, agriculture, and so on. So I envision the need to get together largish groups of people who are specialists in different areas who would work together in order to develop scenarios for what is likely to happen here. And if somebody could find a donor with several million dollars available for this is about what preparing realistic scenarios would actually cost. Okay, the next thing to help planning would be to think about essential features of today's society that we want to keep. So I have a couple examples here: refrigeration, basic medicine, and so on. So how would we structure a greatly simplified post-collapse society in order to continue to provide these very, very important things that we value and have come to depend upon? And I'd like to really highlight the last item here, human rights. Why am I mentioning that? Because I think the availability of cheap energy it's so pervasive. We're like goldfish in the water. We don't even notice the water. I believe that the ability to have human rights it is actually predicated on the availability of cheap energy. And let me just give you an example to illustrate that. Before we had cheap energy, how did people, energy was still important. Energy has been important to human society from the very beginning. What were the issues about controlling energy before we had cheap fossil fuels? Well, for some people, it was slavery. This is how elites sequestered energy and put it to their personal advantage. And in emphasizing human rights here, I am really worried that without cheap energy, we are going to revert to many of the most disagreeable practices of an older world. And I'm very worried about this. We need to think about this now, thinking about how this collapse might happen, how we can avoid this retrogression to a kind of society that we really would find intolerable. My last point here comes primarily because I'm a university professor, and the prime job of the university is educating young people. And as I said before, I've been paralyzed because I don't personally have a good message that's very useful. If I could speak honestly, here are the things I would be saying to young people today. The first is expect to be severely tested on a personal level. I think this is not going to be easy for you. You're going to be thrown onto your own resources. And don't assume that society is going to continue to provide for your basic needs. You will need some practical skills. You're going to need friends in communities that are resilient. Get a habit of mind now in which you don't depend a lot on stuff. Don't find your pleasure and satisfaction in buying yet more gadgets. Downsize now and find your joy in old-fashioned ways with friends, family, nature, service, and your own personal creativity, not tech. And the last point is cling to what is good. And it relates to my remarks about human rights a few seconds ago. I do really feel that this transition is likely to bring out the worst in human nature. And it will be important for people going through it, if it's going to be negotiated with any success, to have a vision for the future, to have clear values. What do you want to preserve? What is good? What is important? And to cling to that, despite all the forces, negative pressures, and challenges that you're going to be going through. So that ends my talk, and I'll be very interested to see what comments people have on it. Thank you.
Sandy, thank you very much. And I think we'll turn it right over to Mariana Grossman, who is the respondent to your talk. and then open it up for other questions from the chat or from other presenters and respondents. Mariana, do you want to jump in?
Okay, there, I hope people can see us. Thank you, Sandra, for that powerful wake-up call. And I could argue with some of your premises, but I think the shift from trying to prevent catastrophe to planning ahead and dealing with it as it's coming, naming the warming pot that we are being boiled in, rather than just thinking it was a nice relaxing hot tub for the frogs, is really important. And as you were going through your presentation, I was thinking of counterexamples. There are people developing batteries or other energy systems that aren't fossil based to do heat for steel, and there's other building materials. There's nitrogen fertilizer that's bacteriologically based rather than fossil fuel based. So there are solutions in the pipeline. And on the survival side, there have been a lot of really innovative work done in developing communities for solar cookers and things like that that are to replace kerosene or other fuels. So there are lots of examples that we can learn from. And I think if we can continue to have a globally connected set of innovators, then focusing on local resilience, I think, is really important. And then also looking at something you didn't mention, which is when you have migration and starvation, you have conflict. And we seem to be willing, at least in this country, to pour unlimited funds into the military responses to conflict. And I don't know if we can change that so that we're spending all that money working on solutions instead of on destruction. That would be something that I think citizens and policymakers and corporations could collaborate on. And I think waiting for oil to run out is not responsible. I think we have to figure out how to stop subsidizing oil and then removing their license to operate, and figure out how do we run society on other resources, and maybe at a different scale than we have been. So I'm wondering what you're seeing. For example, in the University of California system, there's a new Climate, Health, and Equity Center that's doing really important work. There's lots of work going on at Stanford with research and innovation. What do you think that the academic world can do to start contributing to this transition and not just either ignore it or wring our hands about it?
Well, those were my 3 points. They were written primarily from the standpoint of somebody at a university. What should a university be doing? So let's take the first point, which was realistic scenarios. I certainly agree with you that there are lots of studies out there looking for new approaches. Here's my question: I would like to have a better idea quantitatively of to what degree and how fast these solutions could be implemented and really make a difference. So it's not good enough from my point of view to know that people are working on different industrial processes, et cetera, et cetera. What I would like to see urgently is a team of knowledgeable people looking at each one of them and doing the math, as Tom Murphy at UC San Diego has put it. Where are the atoms? How are they going to move? How much energy would it take in order to construct these new facilities, et cetera, et cetera? So I don't think, I think therefore that universities should be taking the next step to tell us how realistic the implementation scenarios actually are. In addition to just providing the basic research that might make a difference, which is
And I
what.
think it has to be more than just how realistic, because I think that, you know, the cell phone, the smartphone wasn't realistic until Steve Jobs put it together in a way that was enchanting and had a incredibly fast adoption. So I think sometimes from a model point of view, you can't predict the amazing transformations that can happen. And that's where I think the innovative skills come in. Abdul Khan from the state of California has a question. Do you see any significant role for human genius and innovation in being able to tackle the societal collapse that you're foreseeing?
This
No,
will
I
have
mean-
to be the last question because we'll have a longer discussion later. This was the short Q&A, but that's a good question. Go ahead, Sandy.
Okay, so your remarks and this question are exactly on the same topic that I'm trying to address. And I will point out Simon Michaud's studies, which I think are so valuable. As I say, he looked into whether or not we could rebuild the electrical grid with renewables. Now, there could be amazing technology that's associated with that. But the fact is, it takes a certain number of atoms of given type. Do we have atoms of that sort at our disposal on the requisite timescales? In some sense, my problems, my questions are one level below and more fundamental than what I hear other people talking about. So that would be my.
And I think part of the
My
challenge is
fine.
rethinking the system. For example, you can disaggregate the grid. You don't have to, you know, it's like saying we had landline copper wire and now we have mobile phones. So sometimes those studies can miss an opportunity for transformational change. So I think
Okay.
your I just want to thank you for your provocative and powerful insights, and I appreciate your courage in taking telling a difficult story. It's really important. Thank you.
Thank you.
Yeah, thank you very much. Patrick, you're up next, and I just wanted to say that I'm very grateful to Sandra Faber for enrolling some of her associates who are interested in the Earth Futures Institute. And for me, it's quite inspiring to see cosmologists, astronomers, and planetary sciences turning their attention to the dilemma of this planet. It will take a large critical mass, and I'm encouraged, even in the midst of the bad news. Patrick, the folks have your bio, but you can say a couple of words about yourself.
Sure.
And then launch.
Okay, so I'm Patrick Twang. I'm a faculty member in the Department of Earth and Planetary Sciences at UC Santa Cruz, and more and more a member of the Earth Futures Institute that Sandy founded. My normal research is to study clouds, like atmospheric clouds, not like computer clouds, in order to understand their impact on weather systems and Earth's climate, and how pollution interacts with clouds. And so over time, I sort of got more and more interested in the bigger picture of climate and climate change, and sort of ended up here after after a couple of decades of thinking about this and going down the wormhole or going down the rabbit hole. It's become a very different question to what I thought I was sort of talking about 20 years ago. So let's see, I'm going to do full screen here. All right. So first, I'd like to thank a bunch of people. Sandy, Rick is on the has been chatting. I can see that, and a number of other people. Not all these people I know. They're just people who talk about these things publicly, write about them, make podcasts or whatever. So I guess what I want to talk about is a little bit like Sandy's point number one, which is sort of like the scenario building. Like, how can we build scenarios of the future that are sort of consistent with the physical world? So the one way to sort of frame this is that, what are constraints? If we want to go towards a fossil-free world, what are the constraints on this world? So like Sandy, I am not trained in about 90% of the things that I'm going to talk about today. So again, just like I think I liked what Sandy says. Like, I'm going to say things with some certainty. I probably shouldn't in most cases, but I try to do my best to stay on firmer ground. So anyways, push back, please. All right, so just real quickly, I think maybe many of you already know how the world works currently, right? So I consume about 2,000 calories a day, which turns out to be 100 watts. So I'm a 100-watt machine, powered mostly by wonton noodle soup, if I had my choice, but unfortunately I don't. And then backing me, because I live in the United States, is about 100 equivalents of me. All right, so about 10,000 watts or 10 kilowatts. All right, so these are the energy backers behind me that do most of the grunt work that I don't want to do, of which there is a lot. So that's kind of how our society is built. The European Union has more like 43 backers, and the Global Green Person has more like 24 energy backers behind them. At the same time, we're not just backed by energy, we're backed by a heck of a lot of materials. Right? And so this is a great figure that it was at least translated into metric, but we're not going to go into details, but the idea is there's a heck of a lot of stuff, raw materials that go into supporting our lifestyles. Includes, of course, petroleum, includes phosphates for fertilizer, cement, copper, iron ore, etc. Right? So one way to think about the sort of the present day world is that you combine energy, whether it's oil, natural gas, hydroelectric, the grid, right? And you combine it with raw materials, copper, water, phosphate, sand, wood, whatever, all the materials, and you get, right, modern society. So it allows you to make steel, petrochemicals, right, grow food, manufacture, transportation, healthcare, consumer goods. All right, so that's kind of how the real world works. I would say that the equation needs a couple additions. The first is that modern society lives off the leftovers after you account for the energy and the raw materials you need to get the energy and the raw materials. So, right, to build the Moss Landing power plant, which is close to Santa Cruz, you needed materials. You needed a heck of a lot of concrete and metals and other things and energy to do the construction. And to secure these raw materials, also you need equipment and a heck of a lot of energy to dig a very giant hole. So really modern society gets to use the energy and the raw materials that are left over after we get the energy and the raw materials. Right? So the leftover, the remainder, is what we sort of live our lives on. And the other part of modern society that unfortunately is true is that we don't really do a good job of cleaning up after ourselves. So we are in this predicament partly because of accumulating waste products, which we do not clean up. Right? So we have accumulating carbon dioxide and microplastics and all sorts of different things. We have mass extinctions of insects and birds and reptiles, etc. So this is kind of how modern society really functions, I would say, in the sort of the biggest picture sense. The other factor, which of course Sandy has touched on, but I just thought I'd show you a little data. All right, so this is global GDP on the x-axis and global energy consumption. And this is data that stretches over a century. So from 1900 to 2018. And the point is that, right, the global economy really is to a very large degree associated with energy consumption. Right? So you need energy to run the economy. And in order to grow the economy, you need to increase energy consumption. And on the right panel, we have a similar thing, except here we have global material stocks. So this is just raw materials, just measured purely in mass. So not differentiating between wood and iron and copper. But the idea is that we also need increasing amounts of materials to maintain this sort of economy. And economic growth is averaged over a long period, something like 2.3% per year, give or take, which is a doubling of about 30 years, which is a very useful kind of, which is a very useful sort of rule of thumb. If you want to sort of think about how fast human society grows, it doubles every 30 years, which is sort of an astonishing idea in many ways. All right, so, and then I guess the last thing to note is that, right, we define a healthy economy as one that's growing, right? A recession is defined as an economy that has stopped growing. And if it goes and it starts to shrink, then, you know, even worse words like depression and recessions and things like that are involved. So by definition, a healthy economy is a growing economy. That is just how we've built the system today. And then this is sort of inspired by Bill McKibben's article from almost more than 10 years ago now. So this is, I added up all the natural gas, oil, and coal reserves, right? So that's about 780 gigatons of carbon. So the x-axis is cumulative carbon emissions in this measure of gigatons of carbon. The y-axis is the temperature anomaly relative to pre-industrial. So if you just take where we are now, which is 2023, all right, you tack on 780 gigatons of carbon, which is, right, just to be clear, this is proven reserve. So this is carbon that the energy companies of the world have essentially put on their books as having a value, which turns out to be at least 40 trillion. It might be 100 trillion. I'm not sure. This is not me. I think 40 trillion is the smallest number it could possibly be, is the value of all this. So in other words, the energy companies of the world have $40 trillion worth of inventory, 780 gigatons of carbon. And if we were indeed to burn all of that, it takes you up there. Then you go up to sort of a reasonable estimate of what the temperature sensitivity is, and you get 3 degrees Celsius of warming. All right, so this is a sort of a radical amount of warming. Avoiding this would require asking these huge companies to remove $40 trillion worth of assets from their accounting books. That's what we're facing. We're facing $40 trillion in assets. And oh, by the way, you got to take all that exploration equipment and budget that you have and zero it today, because we can't find any more of this stuff. Because otherwise, once you find it, then you're basically, in some sense, maybe committing to burning it. Right? And then just to sort of put $40 trillion in context, U.S. federal budget is about $6 trillion a year, and U.S. GDP is $23 trillion a year. So this is a not insignificant amount of money that sort of we're dealing with. Okay, so this is not good. So let's think about how we might choose a different road. Right? Let's not go to a 3 degrees Celsius warming world. Right? Let's not burn all this carbon, et cetera, et cetera. So what kind of roads are available to us, I think, is sort of the question, right? Like, does society have to look like this? You know, the Wild West. Can it look sort of modern? I purposely excluded cars from this picture. You know, is it public transportation and bicycles, but maybe otherwise looks the same? Is it a Dyson sphere or a ring world or the Jetsons? So my sort of thinking is that let's redesign human society so it can last for a long time. In other words, that there's no planned obsolescence of sort of this new society that we've built. And then what are the physical constraints within which we have to design the society, right? Which of these designs work within these constraints and which do not? I kind of define long-term as maybe tens of thousands of years to 1,000,000 years. People sort of recoil when I say these numbers. I want to be clear that I'm not trying to predict what the world is going to be like in 10,000 years. I think that's sort of foolish. But the idea is that let's design something so that it can last for that long, so that we don't have to go through this yet again and potentially face societal collapse, as as Sandy is sort of talking about as being inevitable, right? Let's not do that. Let's build it so that we won't have to face sort of massive transition in the future. And if it gets better, right, if we can do better than this in the future, then, yay us. But let's at least design it so that it can last for quite a long time. And once we have an idea of what sort of designs can fit within the box that we're actually given, which is Earth, or maybe the solar system, then we can sort of think about how we're going to get there. But let's sort of think about what the box looks like. What are our constraints? What can we do? So there's not enough time in 20 minutes or so to really talk about everything, but I just want to talk about a couple of basic constraints. Right? So the first constraint Sandy already sort of touched on, but the first constraint is that, and I think it's sort of like it's like the one ring that rules them all. This is the one constraint that rules them all, that unless we replace a system, a society that relies on economic growth with a steady state economy, then nothing else matters. And I'll sort of explain why I think that's true in a second. Right? So if you just take 2.3% per year growth and you extrapolate it out, you end up with some crazy numbers. Right? So this is from Tom Murphy, who Sandy already mentioned. All right, so in 300 years from now, basically we would have to cover every square foot of land with solar panels, assuming 20% efficiency of conversion to electricity, right? In 300 years, which is not, right? 300 years is essentially the industrial age. So another industrial age from now, the amount of energy we would need to maintain 2.3% per year growth is like no room for anything other than solar panels. And then you can go out another, 100 years or so, and then now we have to cover the entire land in solar, assuming that we can now convert that solar energy at 100% efficiency. And then another 50 years beyond that, we actually have to cover the entire Earth in solar panels. So, and then you can go even crazier numbers, right? Like all the sun and whatever. So, but the idea is within like centuries, which is not a crazy time period to think about, we're going to have to harness sort of ridiculous, I use the word impractical to be sort of a little bit more careful, sort of impractical amounts of harnessed energy, which will, of course, require impractical amounts of materials. So it's pretty clear that energy growth, no matter where the energy comes from, on the time scale of centuries is just not possible. Right? It's unphysical. The other thing that some economists like to talk about is like, oh, well, what happens if we can grow the economy without growing energy? It implies things like economic activity that requires zero energy and zero materials. Some economists seem to think this is possible. I don't really know what world they live in. To me, this seems ridiculous. And it also has to be, if you just keep growing, the fraction of the economy that requires zero energy and zero materials will slowly increase and asymptote towards 100% of the economy, which sounds absolutely ludicrous. So I don't think this is plausible. Again, some economists don't agree, but again, not sure that's physically consistent. So this is sort of the first constraint. Like at some point, we're going to have to cease to grow energy. And that requires that we cease to define an economy to be healthy when it's growing. And so we're going to have to redesign society to fit a steady state economy. Now, this is sort of an absurd thing to think about on some level, because the current economy is so this is so ingrained, like things like that Sandy mentioned, like interest rates and investments and all these things sort of require this idea of growth. So nothing we do will matter, I don't think, until we literally tear down the current economic structure and then redefine it as being healthy when we can, say, provide for everybody without growth. That is, I think, the first constraint. Without that constraint, nothing else matters, because energy growth and material growth will just cause everything else to become more and more problematic. So that's my first constraint. Let's see. All right. So the second story is kind of about the raw materials that we need to obtain energy and how much raw materials we have left over after we harvest them and use them to secure energy, right? So Sandy has already kind of touched on this. Most of our energy will, in a fossil fuel-free world, will be solar plus wind. But how much can we make, right? So this is the question of how much of solar and wind is possible. So why is it solar plus wind? Well, right now society is 20 terawatts. Sorry. The surface
We're going to have to wrap
absorbs.
up in a couple of minutes to leave a room for a question, Patrick.
All right. And I'm going to hurry through this part. All
Okay.
right. So building solar and wind requires raw materials. If you look at, so this is just United States copper ore, but sort of the global trend is similar, that copper ore quality has dramatically reduced over time. And the problem is, as you increase the quality of copper ore, as you decrease the ore grade of anything, the energy it takes to secure that, in this case copper, goes up tremendously. Right? That's from just mining 10 times as much rock and the grinding and all that sort of stuff. And this is actually, I think, a really useful quote from Barty. It says, limits to mineral extraction are not limits of quantity, they're limits of energy. Extracting minerals takes energy, and the more dispersed the minerals are, the more energy is needed, right? So let's just say that magically we managed to construct an infrastructure of solar and wind that meets our societal needs. It looks sort of like this: solar plus wind plus storage. All right. Congratulations. Now do it again in 20 years, because that's about the lifetime of all this stuff. So in 20 years, you got to scrap the entire system and rebuild it. So as Alice Freeman says, wind turbines and solar panels are rebuildable, not renewable. So we have to rebuild this structure again, this entire infrastructure, every 20 years, all right? This is a huge undertaking for which we may or may not have enough materials. So the question that we're sort of trying to think about is, what are the material bottlenecks in this rebuildable world, right? Either energy bottlenecks or material available bottlenecks of materials like lithium and neodymium and whatever, right? So this is kind of the project we are currently sort of engaged with. And you might be able to tell from my tone, I'm not super optimistic, but in any case, the idea is to sort of think about what is possible within these constraints, and then try to understand what sort of societal scenarios are available to us. So I think that's pretty much all I wanted to talk about. The story continues, but anyways, for now, we'll pause there.
Patrick, thank you very much. That was a very thorough and it's interesting. I don't want to say discouraging, because it's we have to know what we're dealing with to have any hope at all of a transition. I'd like to turn it over to John Wells for a response. Quick one, John, and then maybe there'll be time for a question or two. And we do have a 25 or 30-minute discussion at the end for following up with some of the questions in the chat for those of you that are firing in comments and questions. John, go ahead.
You're muted, John.
I'm self-muted. I'm unmuted now. Thank you, everybody. Patrick, I'm looking out my window right now and I'm seeing a woods out my backyard and it looks beautiful and the sky is blue. And, you know, I drive, I don't work, I'm retired, so I don't have to run to work every day, at least 5 days a week. So the world is pretty good, although I do like to fly to Europe and see what the rest of the world feels like. I want you, Patrick, to, as you talk about, Americans use 5 times as much, I think it's just to say energy and raw materials as the global mean person, and 2.5 times as much as Europeans do, or European Union folks. And you also want power companies to give up $40 trillion or perhaps more in their assets. I want to know how you want to do that, but how you would do that. But I want you to think of yourself as the emergency room medical doctor. You're a cardiologist, you're a surgeon, you're a psychiatrist. I'm your patient. Actually, and I don't believe there's anything wrong, but my heart's failing. I'm injuring myself constantly. I'm hurting myself, and I don't know why. I'm planet Earth. What are you going to do in that emergency room? How are you going to make me think there's something that needs to be fixed? And how are you going to fix it in the time frame we need it fixed?
Solve my problem. I'd say if I knew that, I would probably tell you how to do it. I don't know, but I think part of it is I don't know what's possible yet, right? Like everyone talks about the green transition. Like, I'm not sure we even know really where we're going. Like, are we just gonna make changes willy-nilly and hope like that whatever destination we end up at, like we transition to, is gonna like work out for 8 billion people, 10 billion people, 12 billion people, wherever we're headed? Like, I don't know that this is there's no plan, right? And I think part of the reason there's no plan is because we don't know what a reasonable destination is. We're just kind of, right, like right now everyone's sort of talking about like, how can we tweak the current society? Like they're putting a band-aid on, this patient who's having a cardiac arrest, right? It's like, oh, we built a better band-aid. Like, congratulations, the patient's still gonna die. Yeah. So I don't know if there is an answer, but I think part of it is, thinking longer term about how the entire world is restructured and what is possible within that. And so until then, I don't know the answer. I don't know how healthy I can make you, maybe is the analogy, right? Like,
I'm hearing
I can fix your leg.
I'm hearing crash coming.
I can fix your leg, maybe, and maybe that's as much as we can hope for, but maybe, so I don't know. It's probably a very unsatisfying answer, but I think it's the truest.
It's actually an answer that corresponds to what we really know collectively. I'd like to call on Alexi to come forward. Alexi, you can take a couple of minutes. Thanks, to introduce yourself. Thank you very much, Patrick, for that.
You're very welcome.
We're a little behind schedule, but not terribly, and I'd like to preserve some time for discussion. So I'm going to get out of the way, and Alexi, you can launch.
Thank you, David. Can you hear me okay?
Yes.
Okay, great. So my presentation today is about action, and I'll also tell my personal story of how I got to the point where I am. My talk is called From Dark Matter to Dark Matter, because I've come to believe that certain things that we do, certain professions, it's time to stop doing them and move on to other things to tackle this crisis and this urgency. And so my subtitle is The Cosmos Can Wait, because I believe that some fundamental research is no longer going to be relevant for maybe the next few hundred years, and we should focus instead on other things. So this is my personal trajectory. I'm a professor at UC Santa Cruz in astronomy and astrophysics. I study the origin and evolution of the universe. In particular, I study dark matter and dark energy. How did I come to this point? I decided to develop a big picture undergrad class. It's called From the Big Bang to Planet Earth. And in the context of that class, I taught myself a lot of new things. I talk in that class about why we won't move to Mars, why Earth, Venus, and Mars are so different. And I talk about current and future challenges for life on Earth. And through that class, I really came to realize the depth of the problem that we are in. So since 2020, I've been gravely concerned about the polycrisis. Compared to many of you, I'm a newcomer to this thinking. So as Sandy, I offer humble thoughts on this topic. I've come to realize that astrophysics is a highly specialized profession. Like many of the things that we research and study, it's a product of a thriving civilization. And I've come to believe that it would be a better use of taxpayer money, since I'm paid through taxpayer money, to work on the current predicament and to leave this kind of fundamental research to future times. My line of thinking is really well summarized by this paper that came out recently, No Research on a Dead Planet, Preserving the Socio-Ecological Conditions for Academia, which I refer you to at the bottom here. Okay, I'm going to briefly step through 4 sections. One is just some cosmic background, thinking about the role and future of academia. And then I really want to talk about action-oriented projects. That's my 3 and 4. And everyone is going to react differently to this information. And some of us may want to, take action and start changing our lives. And so that's what I've started doing. And so that's sections 3 and 4. Okay, so a cosmic background. Earth is an oasis for life, but it is surrounded by vast, vast emptiness. It's hard to imagine the emptiness that surrounds us. That's something that I teach in my class. We do visual activities that help us visualize this vast emptiness of space. And we're not going to move to Mars. I'll skip the details, but that's just impossible. And we're not going to move to distant exoplanets. I was inspired by this phrase from a 10-year report that my community writes. That is indeed something that my profession is doing right now, looking for habitable worlds elsewhere. The work that we do is decreasing the habitability of our own planet. And the irony of that is just striking. We have transgressed 6 of 9 planetary boundaries, according to the Stockholm Center for Resilience, and we're already using the resources of 1.75 Earths, which are the talks that we heard about earlier. So we must transition to an ecological civilization, and exponential growth on a finite planet is just not possible. There is no plan B. These are the 2 outcomes. So one thing I like to talk about in my class is Fermi's paradox, which basically states, if the galaxy has so many stars and so many planets, we've discovered many planets, many of which are habitable. The question is, where are all the aliens? Why have we not heard from them? Why have we not seen them? Why have we not got communications? And there's many different proposed solutions. Some that I think about and teach in my class is maybe there are several outcomes. Maybe civilizations tend to self-destruct when confronted with these very hard planetary boundaries. It's going to be very rare when any civilization can move to a different planet. That's going to be very, very rare. So there are very firm, hard planetary boundaries. Or maybe they transition, they're wise, and they transition to an ecological, they down low footprints, and they realize that spending resources on interstellar travel, trying to survive with these hard limits, is the best way forward. So another thing I think about is the role and future of academia. I do think astronauts have an important role to play because we have a very big picture. Overall, academia has not risen to the earth sciences side. Most refer you to this paper below, which kind of states the obvious, but fundamental research depends on the conditions, getting food and drinking water and getting a salary. So I think we need to fundamentally restructure academia to encourage more climate action. My own personal opinion is that everyone should now be working on this problem to some extent. I think we need fewer research papers and more boots on the ground that could take the form of community outreach, sustainability research, how to change societal values. There was a lot of chat in the chat about that question. We have a lot we need to support, learn from Indigenous peoples and small farmers, and education, how to prepare students. That was a topic that Sandy talked about. So on this topic, one of the actions that I'm taking is I'm organizing a high-level meeting on this topic in 2024. We have deans from Harvard and Berkeley, UCSC, high-level administrative meeting to think about this question and write a white paper with suggested paths forward. And in general, as the previous speakers have said, we just need more high-level thinking on what the future will bring and how we could transition to an ecological civilization before we perish. So my third topic is about rebuilding resilient communities. Sandy showed this picture, which I believe might be of Hong Kong. And the two previous speakers raised the question of how do we build resilient communities? And I think perhaps one form of a resilient community might look more like this. Small to medium city, town, using a lot more local resources and having a higher level of autonomy. And if we look at how, for example, how Europe was structured in the past, this is a picture from France because I'm French. This is how Europe was structured in the past. Lots of little small towns that were much more resilient. And I'm going to point you to this paper from the Post-Carbon Institute, The Future is Rural, Food System Adaptations to the Great Simplification by Jason Bradford, with more information about sort of this line of thinking. So I'm going to give you an example from France because I'm French and it's just a biased example, but I visited this place a few years ago when I was visiting family in the Cosse. It's a high plateau in France, sort of southern mid-France, has very hard physical restrictions, very harsh climate, high altitude. Soil quality is extremely poor, heavy snow, few forests, so no wood resources. And the buildings are built from local materials alone. And this was amazing to me. There's no groundwater. It's limestone, so the water just trickles through. And they survived on water collected thing. And as you visit these old sort of compounds, villages, you really discover that they had a lot of autonomy and a lot of skills. They knew how to work livestock. They had bread making facilities. They had little workshops to work stone and metal and wood. And I think that's really important to think about. And I'm going to talk about that in a few seconds. Personally, to have hope, I'd like to hold out for a hybrid with some modern conveniences and many rural elements. And talking about what that hybrid might look like, I think would be a great insight to two different topics. One is about cisterns and the other one is about autonomy. So, when I came to discover these topics, I decided to take action and work on things that were trying to change the way in which we live here in the United States. This is a project called Tank to Table, funded by the UCSC Center for Coastal Climate Resilience. And inspired by those cisterns in plateau of France. I've been thinking about how much rainwater we can harvest in Santa Cruz. Santa Cruz is in California. Thinking about how much rainwater we can harvest and we can grow using harvested rainwater. So here I'm showing systems that we're deploying and testing, harvesting rainwater, rain garden, and then the rest will serve to irrigate garden beds over the summer. We're working on testing water conservation strategies, whether with compost or compost teas. And ultimately trying to deploy demonstration sites so the community can come and visit and get inspired to kind of engage this sustainable living style, and organizing community workshops. Okay, the second topic about trying to learn new skills. It's clear that the global north has become heavily specialized. Astrophysics is a perfect example. I study dark matter and dark energy. but yeah, I don't know how to food, and I would die within, you know, a week or two if I was left in the woods. And I think resilient communities are going to need to learn how to draw more from local resources, focus more on relevant specialities, less astrophysics, more builders, more fixers, and also have people become more generalists, grow food, basic medicine, build, etc. Again, I'm really new to this, so a lot of what I'm talking about today is ideas that I'm interested in. I haven't necessarily worked on, but I'm very interested in concepts of villages. I think about and villages, you know, traditional villages.
Alexi,
What are their
sorry to
inputs
interrupt.
and outputs,
Your
energy use, and skill sets? And I'm showing. Yeah.
your voice is wavering. Maybe if you turn your video off, the quality would be better of your
Yeah.
voice.
Yeah, I'll do that. Yeah, sorry, I'm in a campsite right now. So I'm interested in talking about whether we can create today skill centers. We could already create this, a community place where we could learn basic skills such as woodworking, animal husbandry, growing food, basic medicine, birthing, and fixing things, etc. Another topic that I'm interested in is thinking about how future landscapes might change. So, you know, since the 1800s, we've seen the sizes of farms increase thanks to industrial agriculture, and farm workers are now less than 2% of the population. But I believe that as we hit these firm limits, we're going to have more people by need, by necessity, going back to the land to try to grow food. So I'm interested in working on modeling how farm sizes and rural populations might change so that we can anticipate and work on zoning laws. How are we going to break down these big farms into smaller units that are smaller, more regenerative and organic farms? That's sort of like a research question that I'm interested in. Okay, so to transition to an eco-civilization, I think it's clear that we're going to need more people growing food sustainably. And the conclusion that I've come to is the research that I was trained to do, dark matter and dark energy, can wait. You know, the cosmos has existed for billions of years. It's not going anywhere. We can think about dark energy and dark matter in a few hundred years. But until we are an eco-civilization that is thriving once again, I think these topics can wait. So another sort of action item that I've started is thinking about growing food in a time of crisis. We know that food shortages are predicted, and people turn to gardening for food security in times of crisis. World War I, COVID-19. Here's an example of the victory gardens of World War I. During COVID, many people turned to gardening. I was one of those people, went online, immediately bought a bunch of seeds. Seed shops were totally empty, couldn't buy any seeds. But so I'm anticipating that large numbers of people will be looking to grow food in the future. But the truth of the matter is that growing food is very difficult, much more difficult than we think. And gardens are typically abandoned once the crisis, you know, ends. The victory gardens were abandoned, and COVID gardens have also been abandoned. And I'm going to quote John Jeevons from Ecology Action: to become a fully experienced food grower takes about 10 years. And that's just too long. If we want people to grow more food locally, it has to be made more simple. And so that's the goal of a project that I've started called Seed Spoon Science. And the goal is to reduce barrier to entry for first-time food growers. And there's a connection here between astronomy and gardening. Both have very long time scales for experimentation. In astronomy, if you go to the telescope and try to collect data and you get snowed on and the telescope is closed, you have to wait an entire year for the Earth to go around the sun to be able to see that patch of the sky again. And so, you know, it can be very slow. Same with gardening. If you plant something in the spring, it gets eaten by bugs, you might have to wait an entire year to try that experiment again. So the project I've initiated, Seed Spoon Science, is about harnessing citizen science to collectively work on this problem, to experiment better and faster and create mappings between the varieties and planting timelines and local climate conditions. And by creating these mappings, I'm hoping that we will be able to adjust faster to changing climate conditions. Basically, the idea is that we're all doing these experiments. Everyone who's gardening, who's growing, is carrying out an experiment, but we need to collect and record that so that we can then map how things are changing with time and propose new methods. So this project, Seed Spoon Science, is really a system to share growing knowledge. It's going to be a web-based system, hopefully eventually a phone app that will help share design methods for growing, share regionally relevant knowledge, use citizen science, machine learning, and adapt as the climate shifts. And this is really relevant for the global north, where we've lost a lot of this growing knowledge. None of what I'm talking about is relevant for, more traditional places like India and Africa, where this is already a lot more commonplace. I'm really talking about a method designed for the global north. And what I'm thinking about is how much food could be produced locally if growing was made a lot more easy to carry out. I'm also on a grant that's thinking about how much food waste can be recycled locally, avoiding landfills. Because if you're going to grow food, you want to make compost, and you can take all the organic waste and just grow your food directly. And so a proposal that I have out to the CDFA is to build 50 fully functioning urban gardens with rainwater harvesting, again, just trying to make our community more resilient. So very preliminary experiments that I've been carrying out suggest that a family of 4 or 5 with a fairly small lot, you don't need a lot of space, with 2 4x8 garden beds at night, the size of that compost bin is very modest. And I think in California, where we can grow greens year round, it can produce all of their needs in salads with about 12,000 gallons of harvested rainwater and fairly minimal efforts of about 2 hours a week. Okay, so I'm hoping that maybe gives people different ideas about actions that we can take, thinking about how each and one of us is using our time and energy and resources while we are currently in the carbon pulse, in order to prepare for the future for ourselves and for our children and grandchildren. So thank you very much, everyone. And please reach out if you're interested in collaborating.
Alexi, thank you very much. That's quite a transition. I'm going to turn it right over to Anupam Saraf to ask an opening question, your respondent.
Thank you, David, and thank you, Alexi, for your insightful and thought-provoking presentation. It brought many questions to my mind that I would love to leave you with. I like that you approached the challenge of searching for required actions. I also like your suggestion of not researching a dead planet. This leads me to wonder if you view the planet as a self-regulating living entity as proposed by James Lovelock. And if humans were to become extinct and unable to conduct research, would the planet still be considered living? Is operating within the planetary boundaries sufficient for an ecological civilization? Or should we consider the interconnectedness suggested by Lovelock to ensure the livability of our planet? What change in the ecology of our minds would right actions entail? Would it involve considering how we as a species interact with each other, with other species, with our ecosystems and our organizations? Could the quality of these interactions ultimately determine our survival and prosperity as a species? And if so, how can we foster interactions that allow life to thrive on our planet and ensure that Earth remains a self-regulating system capable of supporting life in all its diversity? Could changing how we understand and interact with each other and the world be the key to advancing our civilization? Alexi.
Anupam, those are really wonderful, insightful questions. Thank you so much. I can tell you've thought deeply about this question. Absolutely, I agree with the concept of the Gaia, the living planet, by James Lovelock. Now, I think we really have to rephrase the question here as, what we are trying to do is save our skins. Life has existed on the planet for a long time, and there have been multiple mass extinctions, the greatest one being 200 million years ago during the Permian, where 95% of life species went extinct. So, we could go extinct, we could create a biodiversity crisis, but the likelihood life on Earth will continue to survive as it did, over the 4 billion years of its existence. The question is whether humans will still be around. And so absolutely, I think life will continue to exist to some extent. Life on Earth will encounter other serious challenges in the future. 5 billion years from now, our sun will go red giant, and that's a serious hard limit we may face. But in the meantime, other life forms will continue to exist. I think the real question is how to save our skins and the other life forms that share the planet with us today, right now. And to do that, I think we need to transition to an ecological civilization where we view ourselves as stewards of the planet. Our goal is not to become wealthier. Our goal is not to have fancy houses. Our goal is not to vacation in Europe. Our goal is to be stewards of the planet, be mindful of our population, and how we impact the other life forms on Earth, and keep the conditions on the planet stable in the way that it has been in the last 11,000 years of the Holocene, under which our modern civilization has emerged. And that's the only way I think that we can survive as a human species. Otherwise, the life will, Earth will become the world of jellyfish and scorpions, and other intelligent life forms will evolve after us. Thank you, Anupam.
Okay, thank you. We are going to have to save other questions for the Q&A. So I'm going to make a spontaneous announcement. Would all respondents check out the chat for a question that relates to the presenter that you're covering? And that way we can capture some of the chat early in the discussion. And I'm going to call upon Ted Hines now to present. Ted Hines is very interested in what's above the atmosphere, but his profession has been down on the ground. You'll have his bio. He's an economist, and he will be talking about growth and collapses. Ted, you have the floor.
Okay, thank you very much. What an amazing set of presentations we've had. And I would like to offer a few remarks in transition from those. One is that I'm going to talk about an economic system that itself has evolved over at least 200, maybe more years, to be incredibly powerful. And the use of fossil fuels is clearly an important part of that. And of course, that means that the power of our economies is now linked to its effects on the climate. But I think it's very important that we understand some really fundamental things about how our economic systems work and how they are linked to the problems that we see in the environment and climate. I've used the term collapse with an S on the end, because I think it's jumping to conclusions to assume that that there will be a single cataclysmic collapse. I think what we're going to see is a series of collapses in different ecosystems and economic systems over the next century or two. Whether that comes to constitute a collapse of everything, I have no idea. Next slide, please. Rhonda. So systems analysts and scientists have known that systems that exhibit exponential growth often experience collapse. So we're very concerned about it because our models, those models show overshoot and collapse in many different ways. The first to present this was the limits to growth work. World 3 is its current version. You can see the various curves here rising up, and then some of them collapse quite directly and some of them less directly, but all sort of about the time frame of where we are now. That's a little scary. Next. So many of the crises that we're worried about in the environment have to do with this, and particularly since the models show that things that grow exponentially tend to overshoot and collapse. And if we look at least the global north economies, they've exhibited exponential growth, roughly speaking, since the Industrial Revolution. That's not to say it grows the same every year, but it certainly takes that over 250 years. Next. So I'd like to talk particularly about feedbacks. Feedbacks have caused this evolution of our economic systems, and in particular, I think they have caused them to become exponential. That wasn't designed. It just evolved. That's really important to use that word, evolve. So the non-economic effects also tend to be exponential and therefore exhibit these collapses. And they have important feedbacks, but they're weaker. So we'll talk about that. Next, please. So this is a really simplified diagram showing actions in the middle. This is a learning system, an evolving system. So actions can have consequences, results that are good or bad. The bad ones cause negative feedbacks. The good ones cause positive feedbacks. In an evolving system, there's a memory. In life on Earth, that memory is mostly DNA. That also involves design. In human systems, we also have planning and deciding before actions are taken. And actions use resources. So I've drawn this very simple diagram because what we call spaghetti diagrams tend to overwhelm the mind when you show them. Next, please. But you can see how complicated these feedbacks and connections can be. I'm not going to go into this at any detail, but you can see debt is an important part of it. As Sandra pointed out, inequality is on the left. Financial markets are an important part. Okay, next, please. So I want to look at 4 key questions. What's driving economic growth? Why is it exponential? What economic and non-economic forces counter these drivers? What might collapse? And what will emerge after the collapses occur? Do we really have a good way of knowing the answer to that question? Well, the key drivers of economic growth are investment in finance. In the modern system, that's banking and the financial markets. It's would be really lovely to go into that in detail today because there's some real issues in what we call fiat currency and the way banks and financial institutes operate in modern economies. Science and technological development are really key here. They've become more and more important, but they, of course, were largely responsible for the technologies that emerged starting with the Industrial Revolution. Technologies also give us efficiency and productivity increases, which means each worker in the system is producing more in dollar terms and able to get higher wages if labor has some leverage. There's also the importance of what I call consumer discontent. Discontent is that we want more stuff. We're not content with the stuff we have now. We're not content with the place where we live. We want a bigger house, a faster, newer car. We're discontent. It's important that that discontent is manipulated by our economic system. And then another important driver is the way governments manage the economic system through their spending and borrowing and through their central banking in particular. Next, please. So each of these drivers experiences strong positive feedbacks when it contributes good results. And those positive feedbacks come from a number of different sources, as it were, in the economic system. These drivers also experience strong negative feedbacks whenever action leads to bad results. Firms go bankrupt, stocks collapse in their value, countries go into recession, and so forth. The feedbacks from non-economic damages, like to the environment and the climate, are relatively weak, at least so far. It's important there to note there that our economic system operates on a really short time frame. Investments want to see returns in a number of years. Loans are typically paid off in 8 years or 10 years. And yet today we've mostly been talking about timeframes of centuries. So how do we think about the relationship between how our economic system now operates and what an economic system might, how an economic system might get into a different configuration in the future? Next, please. So here are just some very specific positive feedbacks. You get profits and returns on your investment if it's successful. Private and government support for research has become very important. Good research and development of good technologies brings more money in. Profits increase from efficiency gains when you can cut costs in your manufacturing or in your distribution. You can make more profits, and the potential is there for wage increases. Profits arise from successful advertising. This is really becoming more and more a part of our modern economy as advertising has learned to exploit internet technologies. A recent article in the New York Times called that fracking our attention and talks about the attention economy. Once the internet made the delivery of information essentially costless, the scarce resource became human attention, and advertising is intensely after manipulation of our discontent. First, it has to get our attention. And of course, political success depends very much on good economic conditions. So when governments can't say or show the people who, at least in democracies, put them in power, that the economy is doing well, then they're taken out of power. Next, please. So the economic system is very good at punishing losses. Investors go broke, people lose their jobs. Even successful investments result in inequality of income and wealth, and those have negative feedbacks. And political failures lead to result from bad economic conditions. You get voted out of office. Next, please. So these are just a lot of examples, thanks to some research on the internet by David. The key thing is that all of these graphs are pretty much the same shape, and they address various different sources or results of economic growth that aren't so good, particularly if on the right-hand side of the edges of these graphs, there is a looming collapse. Next, please. And of course, I would like to emphasize a primary concern with what the climate is likely to do in the collapses, at least local, that climate change is likely to cause. And we have some images to illustrate what those collapses look like on a local scale, at least. Next. One of the things about the way in which our economic system operates is that there are some things that are countering economic growth. We would expect to see increasing costs of minerals. That's been a big debate in the growth versus no growth arguments for at least 50 years now. So far, costs of key minerals haven't increased very much, surprisingly. We're going to see habitat loss. We're going to see increasing costs of fish and probably timber. We see increasing scarcity of water, loss of aquatic habitats, and general degradation of the environment, particularly around dense human settlements. Next. So here's a spaghetti diagram of what some of the negative feedbacks look like. But it's important to emphasize that these are generally weaker than the positive feedbacks that have been driving economic growth. And many of them lag behind the things that cause them. They're not as immediate as the positive feedbacks from economic success. Next. So one of the things I'd like to emphasize about a modern capitalist society is that everyone is a part of it. We are all involved as consumers. We are all involved in some way as producers. Even academics who produce knowledge also are involved in teaching. We're all involved in producing. We're all involved in consuming. Fewer people want less than those who want more. It's very difficult to convince people that they shouldn't want more, that they shouldn't want better. They also want security and respect and status and connections to others. And some of these needs can be met by goods and services rather than just human relationships. Sometimes we rely too much on the status and respect that we think comes from material goods. But it's it's a fact of how our human nature has evolved in this economic system we call capitalism. Next. One of the things that is true is that some of the profits from successful investments in business are used to influence government actions. We're all very skeptical and cynical about that, but it seems to be a part of our political economy that is inescapable. The other thing is that economic performance at every level is quickly experienced and directly communicated. As soon as people start losing jobs, everybody knows it. As soon as prices are going up fast, everybody is talking about it. And the data is there very quickly to show what's happening. Next. So a key thing about how an economic system of the sort we have will continue to evolve going forward is what will be the balance between the positive feedbacks from economic success and the negative feedbacks from the environmental and climate effects. One of the key factors in that is that powerful technologies are still on the way that will boost the power of the economic system to grow and continue this exponential growth. We are hearing a lot about artificial intelligence these days. I think that is going to have huge effects on the way the economic system operates. Some say it will have negative effects. It's quite possible that it will, but it will probably also increase the power of the economic system to keep growing. Another one that hasn't been mentioned is the development of nuclear fusion power. The bottom line for years has been that's always 20 years away. But it seems a little bit closer in the last 5 years than it has before. And it could really change the energy equation. But we don't know what's going to happen with climate change and collapses. That's really very uncertain. We know there's going to be floods. We know there's going to be fires. We know there will be heat domes and loss of life. We don't really know when that will become dominant in human minds and begin to cause change in the economic system. Next. So what can we do to tip the balance? Well, there are a bunch of economists' favorite policies, but the obvious ones are opposed by powerful economic and political forces. And we don't really have equally effective countervailing political efforts to change. Economists would love to strengthen the negative feedbacks by internalizing environmental costs. Many advocated a fee on fossil fuel production as a way of pricing carbon emissions. And that is being done in some places in Europe. It was rejected as being like a tax in the United States. And so we have other government things like subsidies and loans being used to deal with environmental effects. Of course, we could have regulation that just prohibits economic activities that create bad environmental effects. But again, powerful interests campaigned against government regulation. You could tax financial transactions or advertising. That's a favorite of mine. Would raise a lot of money without much burden on the financial markets or the advertising markets. Why we haven't done that, I don't know. And of course, in the US at least, our income tax system is becoming less and less progressive. And the way out of the debt crisis that Sandra talked about is clearly to raise government revenues. And a major way to do that is to increase the taxes on higher incomes. Next, please. So we could also I'm just going to skip to the bottom one here, subsidize things like geoengineering. There's a lot of debate about this eventual success of geoengineering efforts of various kinds. Carbon removal and sequestering is just one of them. They're very costly, use a lot of materials and energy, and whether they could be deployed in enough time to save us from the worst collapses due to climate change is questionable. Next, please. So a big effort is needed if we're going to have political action that can alter our current economic paradigms. A thought experiment that's useful is to try to imagine from your own learning of history where our current economic and political paradigms came from. They didn't come from hard science planning. They came from philosophers, to some extent at least. And somehow the ideas from those philosophers motivated large numbers of people, but they weren't the only motivation, perhaps not even the primary one. I think that the generally pessimistic tone that we've had in the discussion so far indicates some sort of belief that collapses are coming and that collapses are going to be needed to motivate political action to alter our economic paradigms. But a lot hangs in the balance, how fast we learn from those collapses as they arise. And I don't think that the detailed planning about energy and material production, or on the one hand, or the micro planning about how we can have community or family gardens on the other hand, are likely to provide sufficiently strong political action. I'm looking for something else, but I don't know quite what it is. Thank you very much.
Ted, thank you very much. Your years of wrestling with these challenges come through in the depth of your questions and points. I'd like to turn it over right away to Rich Jurisic to ask you an opening question. Rich, you have the floor.
Great, thanks. Excellent talk, Ted. Really a lot of insight there. I'm curious, a kind of an ongoing question. There's always kind of like maybe a gut reaction that distinguishes purely population growth versus economic growth. And I noticed just looking at the world population meter just a few minutes ago, we're kind of hitting that 8.1 billion population on Earth. what can you say about the kind of relative importance in terms of, this economic exponential growth and how that relates to potential collapse and population? Because in my mind, it's not really strictly population growth, it's our lifestyle that's leading to these issues. But is it possible to say something about the relative importance of population versus lifestyle?
Population versus lifestyle. That's an interesting one. I think that first of all, oddly enough, the effects of population growth on national economies as measured in GDP is positive. And all businesses that are investing on the basis of the growth in the market, consumer market for their products, count on population growth. So in societies where we see this demographic transition to below replacement birth rates, that becomes a serious problem for those managing the economy. And we're seeing that in a number of countries. If you look at it at a global perspective, the combination of, well, there's an odd feedback loop, because clearly a major effect of economic growth has been healthcare regimes that have allowed populations to grow. And the demographic transition has lagged behind that by decades. So we have seen this global surge in population growth as better healthcare and better public health management, including basic sanitary services and clean water have become available. We've seen population growth, which means more consumers, which means more economic production. In the long run, we're now seeing the possibility that we'll see a decline in population globally over the coming decades. What that will mean for economic activities is a little worrisome to the growth advocates, because no longer will investors be able to count on a growing market unless they expand into sales in less developed parts of the world. So
Okay.
that connections there.
Yeah, that's an excellent response. So David, how do you want to turn this? You're on mute right now, David, but shall we turn it over to open questions, or how do you want to go here?
Did you spot a question in the chat that you could launch, or we could turn it over to another area?
I don't see any questions. I think John had I don't know, John, if you want to jump in with your question. John Wells.
Which one are you talking about? I put a couple up there.
The one about global movement towards fascism.
Yeah, well, it worries me when we see the Netherlands electing a fascist leader, and Italy apparently did it, and we've got our own risk of that in the United States. To me, what that signifies is people wanting to not let outsiders come in when they're doing okay. And they blame outsiders for when they're not doing okay. So they want to have authoritarians go back to 30 or 40 years ago. So my question to the group is, how do we avoid that if we are to experience collapse or recovery, or as we fight to avoid collapse and have to recover? How do we avoid that natural I assume it's something of a natural tendency.
Anyone want to jump into that?
Well, I could offer one possibility. I don't think it's a matter of avoiding that response to immigration as you laid out. There are other conditions that it responds to as well. But the question is whether those regimes can make good on their promises. They tend not to be very effective over a longer run. And of course, the history of fascism, and I would include authoritarian communism as well,
Yes.
is that those regimes have come in, but they haven't lasted for a century. And because, well, one, they don't run the economy very well, and two, wars are terribly wasteful.
Well, the irony is if we define running the economy well as exponential growth, then we got a problem anyway.
Well, I'm talking about the political effects. They're,
Okay.
because they can't run the economy well, they can't stay in office for very long.
Okay. Thanks, Ted.
Okay, thank you. I'd like to ask any respondent to volunteer to ask a question relating to the talk to other presenters. And then I would invite, in a few minutes, I'll ask presenters to make additional comments based on what you heard, or ask a question to another presenter. So first, are there any respondents that have a follow-up to their presenter based on what they saw in the chat?
A general question I'm
David? Oh,
seeing
okay.
is the most recent one by Denaya is if anyone is seeing moves towards building local resilience in the communities where they live. So I think that's an open question to all the speakers.
Well, I think for sure Alexi is seeing that. Alexi, do you want to comment on building local resilience where you are, and whether that could be viral or spread through other regions?
I think it's tremendously important. I haven't worked on it long enough to have an informed voice as to whether we're seeing it spread more broadly, but certainly from a grassroots movement, that's personally what I'm trying to do. I'm pretty sure there are other efforts out there. One of my next goals is to try to connect with them. I think we need a huge amount of grassroots efforts on this front to build resilient communities. It's going to take time and money and effort. I don't have a whole lot more to say, but yeah.
Could I jump in on that, David? I
Sure.
think part of what Dinya is also referring to is anybody who's in the audience, whether you're a speaker or not, if you're seeing local resilience movements, and if you want to put those things in the chat so that everyone's not talking at once. But I think it's very inspiring to see how many examples there are of those that we could amplify.
Very good.
I'm going
Well-
to jump in on that. I have a meeting this afternoon. There's a proposed 700,000 square foot liquor warehouse. It's going to require an Egan, Minnesota change to their comprehensive plan. The planning committees, I have worry, has already worked out some details with the liquor warehouse company, and it's going to replace a Blue Cross Blue Shield meeting office or home office. So and that's all right within 3 blocks of residential areas. So I don't see that. I mean, there's the mainstream is like, oh, geez, we can get tax revenue from that. I do have another question that I know there's differences of opinion on it, but we are now starting to see, and Ted, you mentioned it, artificial intelligence and its use. I don't know much about it. I'm hopeful that it's not just regurgitating the best of the research we've gotten, but I'm wondering how this movement that we're talking about here might learn from or use artificial intelligence to craft ways of avoiding collapse or responding to collapse if we have it.
Wow.
Maybe that's dreaming. I don't know.
I think I haven't heard any discussion. I've been trying to keep abreast of what's available in the non-technical literature about artificial intelligence. And I haven't seen any discussion there of its potential application to that. They tend to be applications that are totally embedded in the capitalist economic system, or in healthcare, which is partially capitalist in the U.S. And so it's those applications are viewed as economic investments. There are new softwares you can use to do a better job of producing whatever you want to produce.
Maybe Sandra's organization needs to get somebody to wake up and try to tap artificial intelligence for this purpose. I don't know.
Haven't seen any.
Yeah.
David, Alexandra Sokol has her hand up.
Okay.
I was just going to chime in if you guys are interested. I am a member of multiple nodes on the Millennium Project that Jerome Glenn runs. And AI is a huge, huge dialogue and controversy right now. We just got the UN to put in a subcommittee on researching laws. But to let you know the flip side of it, because there's a lot going on that's really frightening. And I was not an AI person till we started talking a lot about it. But there's also, on the positive side, there's a lot of actually going on with AI or use of AI in agriculture. So there are so many pros and cons. I just actually got done watching a Netflix program, which was pretty frightening, called Capture. So if you want to know more about AI and it's a little too close to the reality, I suggest you might want to join the Millennium Group or search out Jerome Glenn.
Okay. Thank you, Alexandra.
Uh-huh.
Are there any? Okay, I see Anupam Saraf has his hand up. And also I would alert all speakers, if you have a question of another speaker or something you'd like to add based on what you heard, let us know. Okay, Anupam, go ahead.
Yeah, very briefly, there are a lot of traditional communities across the world which have been sustainable and resilient for centuries. And somehow the modern industrial society has invented itself in ways which have caused the kind of problems that we are facing and talking about. And so in some ways, should we be reinventing some of the institutions that we talk about and how to go about it? If we are really looking for solutions in the same paradigm in which have caused the problems, how are we going to really solve the problems that we are faced with? So what do we really need to reinvent? Do we need to reinvent the institutions or our relationships with the institutions?
And to whom are you addressing that question, Anupam?
To any of the panelists who would like to. I think Ted talked a little bit about feedback as reinforcing the structures that we have. And so maybe he has some insights on it already about what we may be able to do.
Well, I would say that the institutions we have that are important in our current capitalist economic systems are very well evolved for doing what they do, but they're not necessarily evolved for figuring out how to change to avoid or survive in new ways after collapses begin. So whether they can evolve as collapses begin, I think is sort of going to be put to the test. One of the things I noted in conversation with David about this is so far what we've seen in the US is a tremendous urge to rebuild whenever a collapse occurs. So for my current best example is the town in California that was completely burned out from wildfire called Paradise. Right in the middle of the desolation caused by that wildfire, they're going to rebuild Paradise. Now, I don't know whether that's a good place to rebuild or not a good place to rebuild, but that's just an example of our response to local collapse.
We don't know. I saw 3 hands up. I saw Sandra, and then Rick, and then Alan. So since you've been patient with your hands up, we'll go in that order. Sandra, then Rick, then Alan with comments or questions.
This is a comment on Anupam's question about whether we need new institutions. Here is the way I think about it. I think that there is a reason for everything at its time in history. And you raised the question of, or the existence of, lots of seemingly quite sustainable societies that have existed for hundreds of very long periods of time. And the way they've done that, I believe they're mostly societies that are consuming less energy per person. So the way I think about it is, as the default, we're going to, in the future, after the post-carbon bubble, we're going to have a structure that looks rather like medieval society with much larger energy consumption per person. So the challenge is, think about what that society was and what did you not like about it? And how would you like to change it and preserve maybe more some of the elements and privileges that we have today? And how would you tweak that structure, change it, whatever, in order to make those improvements possible? So some of that would probably require institutional changes to those societies. I haven't thought that through. This was really at the essence of my plea for better scenario building, because I'm having a hard time envisioning how to blend what I think is coming in form of the very old with what we've learned since then and the new things that we would like to be able to continue and incorporate. And without a better
picture, from one to the other. And how to get from one to the other.
Well, I like Patrick's approach in the sense that let's have a vision of where we want to go, and then we can think better of how to get there. So that's very necessary, what you just said. But for me, it's sort of step 2 after the challenge of just even constructing a picture of where we might want to go.
Can I comment on that, David?
If it takes less than 60 seconds, otherwise I'll have to pay Rick and Alan overtime for their waiting.
That approach would substitute the physical science basis for planning a society for the philosophical basis.
Yes.
Is that likely to happen?
Mm-hmm. Because what we've encountered and are encountering is that the physical limits are now setting the schedule and the agenda for us. I mean, no amount of philosophy is going to increase the amount of resources available on Earth by a factor of 10.
Yeah,
So
the
we agree
second
with
law
that.
is pretty tough to get around with philosophy.
True. All right, Rick, you're on.
Okay, so what concerns me is that we're not asking enough of people, what exactly is it that you imagine as happiness? Because capitalism has trained us to feel that we're not enough until we buy such and such product. And if we're stuck in that mode, then all we're doing is we're kind of trying to find better, maybe microscopically more efficient ways, energy and material wise, to create things that ultimately leave us still unsatisfied and help promote the market, which is really just generating a lot of entropy, really. And I'm lucky enough to live here in Santa Cruz, and I spend a lot of time doing trail running, where I'm happiest, and I'm consuming some food, but other than that, I'm not buying anything, and I'm just enjoying what nature has given to me. And I wonder if there's some way that we could think, how could we give people the experience of what actually makes them happy, as opposed to what we're sold to believe is what we need in order to be happy, or to be somebody, to have a presence. The economic system that we've created is just entirely dysfunctional in that regard, and I think we need to pull more deeply away from it before we can even begin to think clearly.
I support that. If you listen to the billionaires, a lot of them do not seem to be extremely content.
Right.
So we can run on that wheel for a long time like a little hamster, but it doesn't seem to help.
Yeah.
So that was a good comment. Alan Frechette, thank you for your patience. Your comment or question, please.
Hi, John Wells knows me. He invited me. I'm an environmental manager that retired about 10 years ago. I built a program in one of the fastest growing counties in the United States. For a little while, it was the fastest, at least. My biggest challenge was convincing the county board to embark on programs that they were going to cause some regulations to be adopted that some of the Republican commissioners would object to. So my focus was to get the public to accept it. And I did that through articles in a newsletter pointing out the advantages and disadvantages. Listening to this forum today was somewhat depressing. What's driven progress in the past in history, I believe, has been profit, potential for profit. The profit potential is there for next generation electrical generation through, say, advanced nuclear reactors that can actually use the spent fuel. The problem is the public isn't supportive of that idea. The National Academies of Science and Engineering published a couple of reports this year, one in May and one more recently, exploring the possibilities for future electricity and then looking at the obstacles to getting the public to accept that. So the big challenge is getting the public to accept something that is good for them. Look at the problem we just went through with COVID, trying to get half the public in our country to accept COVID vaccinations. We failed miserably in that because we didn't have a unified voice. Our educational systems were stymied by internal opposition, and unless we can solve the problem of public perception to get them to understand where we have to go, both in reducing the way we've expended or used energy in the past, becoming more resilient, as some of the speakers had suggested, but also taking a look at where technology might provide some suggested changes. Bill Gates is investing in a next generation fast neutron reactor in Wyoming called TerraPower. I've provided some links in the chat to give you an idea of what potential is. What's holding him up right now is he needs fuel to operate his new technology, and that was only being reprocessed in Russia from their spent fuel from their light water reactors. We don't have any fuel processing capability here. So we need to resolve these problems. The solution is technical, and there is potential for profit, but the opposition is largely amongst my group, the environmentalists, who haven't accepted nuclear power as a clean source of electricity. We've got to get them to understand that the risks of climate catastrophe greatly outweigh the risks from next generation nuclear. That's a challenge for every one of us.
Okay, thank you. We are a little bit into overtime, so if you need to change the channel, thank you for being here. I'm going to acknowledge two more hands. One is a little orange hand from Jim McMahon, and the other one is a hand in the flesh from Ulrich Lonig. And then we will close. I have a couple of announcements to make as the closing. So Jim, go ahead.
Thank you, David. I want to thank everybody for the presentations and discussion. That this is very thought-provoking. I want to take issue with the statement that several people made that we don't have a vision for the transition. There's lots of visions for the transition. Nuclear is one. It's not one I agree with, but there's lots, and they're at different levels. At city levels, at state levels, I put in the chat a reference to California's Energy Future, a study that was done 10 years ago. There's national ones for the US, for other countries. There's a global one by the International Energy Agency. So I think the idea of the transitions, the vision of the transition is out there. To Sandra's talk, which I thought was very good, there's the other level of what should society be like, what should human rights be like, all of that. And that all needs to be rolled in. We're dealing with equity issues and environmental justice. That all needs to be considered. And some of these plans begin to do that now. So I guess I just want to say that the technologies exist to solve 60 to 90% of the climate problem if we implement them at scale quickly enough. And that's a challenge that we're not doing. We need to scale things up by a factor of 3 to 5 in all the areas that we're working on, renewables efficiency and other things. But I just want to say that there are visions about how to do this. It's not a blank slate at all. I've been working on this for 40 years. So I hope that people will pick those up from the chat, and I'm happy to share them in some other way. Thank you.
Okay, you're welcome. A couple of quick comments on that. We are going to share proceedings that I think even we could include the whole rough chat, if you like, other than the private messages, the chat to everybody as an addendum to the proceedings, which will be
Absolutely.
brief. The video will be mildly edited to get rid of a little bit of dead air and sloppy beginnings and endings, and that'll be posted on our website. And I hope that this provokes some cross-pollination. And I will make an announcement about helping to further that after we hear from our final questioner, Ulrich. Welcome, Ulrich. Are you in Scotland at the moment? You're muted, so you have to click on the mic. Scots Wahay.
Unmute. Yes, can you hear now? Yes.
Yes.
I am indeed in Scotland,
Yes.
just south of Edinburgh. It tends to be very dark. It's very far north. If you look at a map, you'll have difficulties. So we use a lot of energy, and I make it as sustainably local as I can. And my purpose of coming on now was, in part, thank you for indeed raising a huge number of questions and stimulating talk. I thought this was an exciting evening. I just want to add one little thought, which I'm sure you know. Donella Meadows wrote when fusion energy at moderate temperatures looked as though it might be a possibility. And I've quoted this recently in a paper. If we had unlimited energy, all we would do is create unlimited waste.
Yeah.
And I think behind that statement is a lot of philosophy, actually. So I just want to put that in without going into the philosophy. I have lots of other comments, but not here and now. We'll do them gradually with the networking that you're promoting, David. Thank you.
Okay, Ulrich, thank you very much. I want to give a deep, heartfelt thank you to everybody who appeared, because a majority of our fellow humans would prefer not even to hear about this. And some of them have spent billions of dollars attempting to persuade people that what we're talking about isn't a real problem. So you are a self-selected group of caring, thoughtful people. And why I put a little energy into having workshops like this and some other projects I'm involved in is to give oxygen to the efforts, and hopefully the more people that can clump and cluster inside the body of the caterpillar, the odds are increased that a metamorphosis will occur and we will turn into something with wings, moth or butterfly. And it leaves a lot behind. So I do think we need resilience to withstand